Okay, good morning, everyone. Thank you for the opportunity. Now I will present about Chapter 12, that is Analysis of Variance, study case about LV Florist. We enter the material. First, I will explain the meaning of analysis of variance. What is analysis of variance? It is used to test whether two samples are from populations having equal variances, and it also applied when we want to compare several population means simultaneously. The simultaneously comparison of several population means is called analysis of variance or ANOVA. We enter the F distribution. In history, the F distribution itself is a probability distribution proposed by the modern statistician Sir Ronald Fisher. Where is this F probability distribution that we can use in the analysis in statistics? The first, to test whether the two samples come from populations that have the same variations. To comparing multiple population means together or ANOVA, and to assume the population follows a normal distribution and on an interval scale. The F distribution have the following characteristics. The first one is there is a family of F distribution. This means that there are various distributions of F that we will be familiar with, which are determined by the level of significance and the degrees of freedom used. The second one is the F distribution is continuous. And the third one is the F distribution cannot be negative. The fourth one is it is positively skewed. And the last one is it is asymptotic. Compare population variances, meaning that we take several samples from the same population, then we will compare whether the variances are the same or different from the same population. These are three kinds of uses in compare population variances. First, using the F distribution to compare the variance values of the two types of sample from the same population. Second one is statistical test use the formula F statistic equals variance sample 1 divided variance sample 2 equals S1 squared divided S2 squared. The third is critical value. Calculated by degrees of freedom, the formula degrees of freedom equal N1 minus 1, N2 minus 2. The study case, for example, with a significant level of alpha 0.05, LV Florist want to deliver an order in the form of a bucket of flowers to some Ratulangi University for a graduate. There are two routes to get there, line A, Manado Tomohon Road, and B line, Tinoor Sea Road. Is there a difference in travel time for the two routes? The travel time for both routes, line A, 52, 67, and so on. Line B, 59, 60, and so on. The answer, hypothesis formulation, H0 is S1 squared equals S2 squared. H1 is S1 squared not equal to S2 squared. The significance level is alpha 0.05. Statistical test F statistics equals variance sample 1 divided variance sample 2 equals S1 squared divided S2 divided. Sample 1, line A, average means is X bar equals sigma X, X1 divided N equals 52 plus 67 plus 56 plus 45 plus 70 plus 54 plus 64 divided 7 is 400 and 8 divided 7. is 58.28. Variance is the sum of the squared differences is equal to between the data values, and the mean is divided by n minus. The data is as follows: 52 minus 58.28 squared plus 67 minus 58.28 squared plus 56 minus 58.28 squared plus 45 minus 58.28 squared plus 70 minus 58.28 squared plus 54 minus 58.28 squared plus 64 minus 58.28 squared divided 7 minus 1. Get the result 39.51 plus 75.94 plus 5.22 plus 176.51 plus 137.65 divided is 485.43 divided 6 is 80.90. Sample 2, line B, the method is the same as before. Here I immediately add up the average means. Average means of travel time is 59 minutes. Variance, the way to calculate the variance is also the same as before. And here I immediately add it up. So the variance for line B is 19.14. After we calculate the value of the first sample and the second sample, we can calculate the F statistic value, where F statistic is the result of the first variance divided by the second variance. We get 80.90 divided 19.14 is 4.23. After we get the result, next decision making. So value of F table in degrees of freedom numerator, degree of freedom equal n1 minus 1 equal 7 minus 1 equal 6. And in the denominator, the F equals n2 minus 2 equals 8 minus 1 equals 7. And at alpha is 5% is 3.87. If the F statistic value less than 3.87, so we accept the null hypothesis. And if the F statistic value more than equal to 3.87, so reject the null hypothesis. Conclusion, based on the result of the statistical calculations, the statistical value obtained are 4.23, or the statistics are more than equal to 3.87. The decision is reject the null hypothesis and accept the alternative hypothesis, meaning that the variations in the creation time of the line A and line B are not the same at the significance level of 5%. The next one is ANOVA. Analysis variance. Analysis of variance, or ANOVA, is inductive or inference statistical analysis method. ANOVA tests two variances based on the null hypothesis that the two variances are the same. ANOVA assumption, the first one, the population follows a normal distribution. The second one, populations have the same standard deviation. And the last one is populations are independent. The independent population analysis of variance is relatively easy to modify and can be developed for various forms of analysis, such as regression. ANOVA stages. ANOVA test stages determine the total variation, which is the sum of the squares of the difference between each observation and the average of all observations. Determine the variation in the treatment, namely the number of squares multiplied by the number of treatments from the difference between the average value of each observation and the average of all observations. Determine the error variance, which is the sum of the squares of the difference in the value of each observation with the average value of the treatment. Here's our ANOVA table, source of variation within sum of squares, SSW, or here's the equation, degrees of freedom, the FW equals K minus 1. Mean squares within equals SSW divided the F within. The F is F equals MSB divided MSW. Source of variation between sum of squares, SSB, here's the equation, degrees of freedom, the F between equals N minus K. Mean squares, MSB equals is SSB divided the F between. The F value, MSB divided MSW. Source of variation, total, sum of squares, SST, here's the equation, degrees of freedom, the F total is N minus 1. Study case, healthy florist measures the sales productivity of 3 kinds of flowers, which is measured based on the number of customers who buy. So roses, 55, 54, 59, and 56. Lily, 66, 76, 67, 71. And sunflower, 47, 51, 46, and 48. Is there a difference in the average productivity of the 3 flowers? Test at alpha is 5%. Here's the answer. Variance total. First, average total. X bar total is 55 plus 54 plus 59 plus 56 plus 66 plus 76 plus 67 plus 71 plus 47 plus 51 plus 46 plus 48 divided in the total is 12. So X bar total is 697 divided 12. So the X bar total is 58. Variance total equals 55 equals 58 squared plus 54 minus 58 squared plus n plus 48 minus 58 squared. So variance total is minus 3 squared plus minus 4 squared plus n plus minus 10 squared. The next is treatment variation or between groups. The first average rows, X bar 1 is 55 plus 54 plus 59 plus 56 divided 4 is 224 divided 4. So the total is 56. Average lily or X bar 2 is 66 plus 76 plus 67 plus 71 divided 4 is 280 divided 4. So the result is 70. Average sunflower, X bar 3, is 47 plus 51 plus 46 plus 48 divided 4 is 192 divided 4. The result is 48. Treatment variation between groups. Variation treatment is 4, 57 minus 58 squared plus 4, 70 minus 58 squared plus 4, 48 minus 58 squared is 16 plus 576 plus 400. So the variation treatment is 992. And the last one is error variance or between groups. Variance error is 55 minus 56 squared plus n plus 56 minus 56 squared plus 66 minus 70, 70 squared plus n plus 71 plus 70 squared plus 46 minus 48 squared plus n plus 48 minus 48 squared. So that's it for me. Thank you guys for your attention and have a good day.